Okay, so this is kind of a response to Excessive Overkill's Aimbot video where he briefly showed his V2 that used this really cool cam-driven mechanism for his aiming. He said that he was having trouble getting it to, be accurate enough, and I was wondering, is that like a problem solving the kinematics for the system? Or is it actually just the driving of this unit is not super repeatable? So I kind of, I like doing solving kinds of kinematics. So I put together this little Python script that'll basically solve it. And what it does is it creates a bunch of points here on like basically a 3D space, and then it changes the perspective, starts kind of with a perspective of these two circles, this back one being your back cam and the second one being your other cam, and it changes the perspective so that it's looking at the origin from the actual target point, which is this point right here, out here in space. So it looks at the origin and it says, here is our two solutions. Wherever these two cross here, once we do the transformation, it's basically we're just looking at this in the XY plane. And then we take those 2 points that are close together as our two solutions, and what we'll do is we'll do a updated rotation so that we're aiming at where those points previously were. And we'll do that step a couple times until we get the accuracy that we need to actually have our solved solution. So when these 3 points are lined up, that's the aiming solution. And it works the same way for the other point over here. And basically you'll have 2 solutions, and wherever your driving position is starting at, say we're starting over here because we're aiming at it a little bit further along, we just find the closest solution to that, and we'll say, okay, so these angles for each of the cams are where we'll need to have this problem solved. So the other way I tried to do this was to make a system of equations, but solving systems of equations with sines and cosines is kind of ugly, and the Python SciPy library that I was using was just going to use an approximation to get a close answer, and then it was giving me like imaginary numbers, and I just didn't want to deal with it. So I went with this numerical approach. And as you can see kind of here on this screen, I have the 2 angle sets that will get the solutions to whatever point that we're aiming at. So that's a really cool thing. Hopefully this helps. And I might make a version of that cam aiming mechanism just to prove that this whole system is functional. As an addendum, I kind of forgot to say one of the nice ways or nice things about solving it numerically, where you're trying to find the closest points here, is that if your target is unsolvable, the rotation basically does this to our graph, and we'll have our closest points will still be the closest approximation to aiming at those points, because this top point here on the ellipse and the bottom point on this ellipse will line up so that it's aiming across here towards wherever our point was. So it's really nice for approximating closest solutions as well.